In this webinar session, we will look into Midas software solutions. So that will be our company introduction. Then I'll talk about the support service that is offered by Midas. Then I'll introduce you to Midas nGen, and after that we will go ahead with its application areas. We will have a short demonstration on an RC building using Midas nGen software solution, just so that you can get a feeling of how easy the software is. And after the demonstration, we will have a question answer session. So any questions that you type at the questions box will be answered by the end of the session. So I'd like to start with the company introduction. Midas as a company was established in the year 1989 by POSCO Group. It's a big giant company now. And since then, Midas has been able to distribute these software solutions in more than 120 countries. There are 540 number of employees, more than 18,000 number of clients, and more than 40,000 number of users worldwide. Midas has its headquarters in South Korea. That's where all our development takes place, software development. And all over the world, there are 9 branches. We have one in China, one in USA, India, Japan, UK, Russia, Singapore, Philippines, and the UAE. Coming to the main 2 business areas of Midas, there is engineering consultancy in the field of bridges, buildings, geotechnical and mechanical works. And depending on the practical requirement of the engineers, these softwares have been developed in the same fields of bridge, structural, geotechnical and mechanical fields. Let us look at a partial list of worldwide users. Midas software solutions have been used by many big companies in all over the world. So they are using either one of our software solutions or maybe all of them. So that takes us to what all software solutions Midas has to offer. Midas is the biggest CAE software developer in the field of civil engineering, and it has 4 family programs. One is bridges. So in the bridges, we have Midas Civil and Midas FEA software solution. So in case of Midas Civil, you can perform a complete analysis and design of bridges. All types of bridges can be easily modeled using Midas Civil software solution, be it a simple girder bridge or a complicated extra doors bridge, suspension bridge or cable stay bridge. Midas FEA is an advanced nonlinear and detailed analysis system. Further, we will go ahead to the structures family program. In structures, we have Midas nGen software solution, which is an integrated system for buildings and general structures. We will see the demonstration of this software solution as well as the next one, that is Midas Drawing. Midas Drawing is capable of providing you drafted drawings, and in those drawings we can get structural plans, elevations as well as rebar details. A rebar schedule is also provided. Midas Drawing is also capable of generating bill of materials. Good part in the structures family programs is that the design that has been performed in Midas nGen is directly used in Midas Drawing to create the different drawings. Then we have Midas Set and Design Plus. which are structural component design and detailing tools. Coming to the geotechnical programs, we have GTS-NX, which is a 3D finite element based geotechnical solution, and SoilWorks, which is a 2D finite element as well as analytical geotechnical solution. Under the mechanical field, there is Midas NFX and Midas FX+. Midas NFX is also very useful for civil engineering works when we would like to perform CFD analysis, 3D CFD analysis. So these are the different software solutions that have been offered by Midas family programs. Now we will go ahead to know about our major strength. And our major strength lies in the support service that we provide. From our Sri Lankan users, we have heard that they have received a really good technical support from our side. It's because they can access to the tutorials, manuals, and frequently asked questions any point of time. They can attend the training programs, monthly webinars that are conducted like we have today, and they can also attend the seminars and workshops that take place at different locations all over the world and also in Sri Lanka. Then you can contact us through online chatting like Skype or WhatsApp, and we can get back to you immediately. There is an immediate help desk. We have globalsupport.midasuser.com, which is a location where all your queries will be stored at one location, and we are able to provide you support services within 24 to 48 working hours. Further, if you have any project related questions and you would like us to actually access your screen to understand what the issues are, then on-demand meetings can also be conducted. Apart from this, I would like to show that Midas nGen has video tutorials online. So such kind of tutorials are there, as you can see in this video. You can get examples of steel structures, high-rise buildings, low-rise buildings, irregular buildings on our website itself. That is en.midasuser.com. Further, when it comes to support, time is very important. So we take care that you receive replies within 24 to 48 working hours. Since all the queries are related to civil engineering work, Midas makes sure that everyone in the company is a technical engineer. We all are civil engineers over here, and that actually helps us to understand your questions better, and we can provide you with a prompt solution. When it comes to location, well, we are located at Union Place in Colombo 3. We come to Sri Lanka for 2 weeks every month, so we can conduct trainings at any location as required, even at your office. So we are easy to access for you. Now we will go ahead to the introduction of Midas nGen software solution. Midas nGen is the next generation solution for building analysis and design. All in all, Midas nGen comprises of analysis tool, design tool, and the drafting tool. The most important concept of Midas nGen is drawing to drawing. We can have integration. That means different business processes are integrated into one software solution, that is Midas nGen. Modeling, analysis, design, reports, quantity takeoffs, all are integrated in one solution. With the automation that is available in Midas nGen, we can actually reduce the time required to go through this entire procedure. Further, we have optimization tools within Midas nGen that helps us to enhance the quantity takeoffs. Finally, there is high quality of design deliverables from Midas nGen as well as Midas Drawing. We actually can get a detailed design report in the form of a Word file. We will see all this in the demonstration. But before we go ahead to the demonstration, let's look into the application areas of Midas nGen. Midas nGen can be useful for apartment buildings, multi-towered structures or a single tower structure, high-rise or mid-rise. In one model itself, you can have steel and RC frames. Then further, you can have shell design also available, or you can have a shell analysis. You can have plate design. Basically, frame types and shell types of elements are applicable in Midas nGen software solution. Complex facilities can be also used in Midas nGen software. Like when we have got drop slabs, then a slab can be located at any depth of a deep beam. We will see this information in the demonstration. Irregular structures, it's very easy to model such kind of structures. So this is one of the application. So it's not only RC but also steel. You get the member design for steel and you also get the drawings generated from Midas drawing software solution. Alright, then let's move ahead without further delay into the demonstration of Midas nGen and see all the benefits that it can give you. So we're going to look at a reinforced concrete building analysis and design as per British standard, and that is BS 8110. So I'll just open up Midas nGen. Okay. So here's Midas nGen software solution. Let me introduce you to its user interface at first. Midas nGen comprises of ribbon menu at the top, which is divided into different tabs. And all these tabs are arranged as per the work procedure from left to right. Then we have various tree menus. Menu related to the modeling, analysis, design, display, and tables. Further, we have properties menu box here. If you would like to know the information of a particular member, just click on it and look over here. You'll get all the information which can also be modified. Then this is a workspace which is again divided into three modes. We have 3D mode which can help us access coordinates at all the in all the axis, X, Y, Z axis. And then we have the plane mode. So you can actually go to a particular plane and work in those two axes only. Then there is story mode. So if we have defined the story, we can actually go to any story and do the modifications of modeling. Now to create a model, there are various methods offered by Midas nGen. Modeling is a major advantage in Midas nGen software solution and can help you to create a building or any structure with very short period of time. So let's see the different methods of modeling. Firstly, we have got import function. You can import a text file that can be generated out of a model from Midas nGen or Midas Gen software solution. Further, you can import your stat files or you can import your 3D DXF or DWG files. The second method of modeling is using tracing. Now, tracing function is actually very interesting. You can import a tracing file, create a story, add a story over here. Let's create one story of 3 meters height. And we can provide this CAD drawing for the 1F level and similarly for the roof. We can click and then we can go to each story. We'll start with the foundation over here, and from here we can simply go tab and select column. Now here, instead of creating a section property, usually the section properties required for a particular project are numerous. You need to go to the section property definition and create all these rectangular, square or circular shaped columns. These are the regular ones. So what we can do over here, instead of going through this entire procedure, simply select the material associated with that section and simply make a box around your entire plan. The program will automatically detect the column layers, and then all we have to do is click on apply. The height is already taken from the story definition. So with one click, all the section properties are automatically generated. So we can press escape to come out of the command, click on a member, and in the properties menu see its section size. So this is 500 by 500. This one created is 250 by 700. And this circle, as you can see, is having a diameter of 900. Similarly, there are so many section properties that the program has automatically generated by one single click. Not just the columns, but also the walls of different thicknesses can be traced easily by Midas nGen. We have over here walls having different thicknesses. Now to create these walls, again, all we have to do is make a box around it. The program will detect and click on apply. I'll press the scroll button, and from the scroll button we can access to any view at any point of time. So it's that easy and convenient for us to change different views. So for going to the isometric view, I have clicked on the scroll button and then I click on this home, and there we go. So as I click over here on this wall, we can see that the thickness of the wall is 400, whereas over here, this one is the same. Okay, this one is 300. So the thicknesses are also automatically defined by the program. Further, you can go to the roof level, and on the roof level, you can generate your flat slab. This building actually is a flat slab structure. So we can have a flat slab. Now what we can do is we can select the periphery and then create the flat slab, or we can even draw our own flat slab. Just simply select the corners Okay, next over here, let me use the easiest option, that is by importing function. So I'll import this center line right over here and put it on the 3 meters height in the Z direction. Alright, and now what we'll do is we will create our flat slab simply using these lines that we have imported from AutoCAD. So these are selected. Okay, let me go in the 3D mode and go to the flat slab. Yes, so we have selected these lines. Now we need to intersect these lines basically. So we have this various CAD features available over here that can help us to create the intersection, the entire model. So I'll just use this intersection option, select all of them and apply. Alright, and let's create our slab. So here we select. Alright, as we select the periphery lines, we can see a preview of our slab and then click on OK. And after that, we are also able to create the openings easily using the lines. So we can go to the openings and select the lines that form the periphery of our opening. In this way, we can generate our entire model by using simple tools and automated tools in Midas nGen. This is one method that I have shown, that is a tracing method. Now I'd like to go ahead to a new model file. We can open n number of projects on one window itself. Alright, so we are done with the tracing file import option, wherein we saw that there is absolutely no requirement of creating new section properties for your columns and new thickness properties for your walls. Now we will go ahead to the next type of modeling method, that is the grid line. Now in many software solutions you have got 2D grid lines. However, in Midas nGen we have a 3D grid line. So this 3D grid line is easy to use. All we have to do is specify the number of spans and the spacings between each span. So 6 at 4 meters and then here 3 at 5 meters. Then I can put a comma after that and say 2 at 2.5 meters. And let's have a single level over here of 4 meters and click on apply and press escape to come out of the command. We can press the scroll button and click on this home to get to the isometric view and look at the entire model or the entire grid line. Now in many softwares, if new softwares have come up with a similar 3D grid line feature, then there is another feature that can fascinate you more, and that's about converting these grid lines into members. So before we go ahead with this, let us define some section properties and material properties. So what we are going to actually do to create this model is we're going to be having a column property, wall property, and thickness property for the walls. So column, beam property and thickness property for the walls, and then the material property, that is we are going to use British Standard database, and we are using C30 grade of concrete, In case of design, we will be using S460 as the grade for rebars for the main as well as sub rebars. Alright, so let's do that. We will go to the Define tab and firstly define the material. In this, we have different codes of practice for defining the steel material property and for concrete material property. From here, I'll select BS and select the C30 grade of concrete from our database. And then we can click on OK. If you are not using the same the grade of concrete from the standard, then you can at any point of time uncheck this code and provide your own information right over here. And let's click on OK now, and we are done with the material property definition. We can check all this information from the model tree menu. So from the model tree menu, here we have the grid line information. And under the properties, we have seen how to define the material. So the new material property C30 is right over here. By default, we have some material and section properties already defined as per Eurocode in Midas nGen. So I'm defining again over here for the British standard. So material property is defined, and next we'll go ahead to the 1D section property definition. It's another window that opens up that helps us to generate section properties of regular shapes or irregular shapes. So here I'm going to show regular shape for RC, solid rectangle, and specify 300 width and 500 as the depth. I'll click on Insert Template, and the section property is there in front of us. In case we would like to do modifications in the dimension of this section property, we can simply double click on their dimension and change the size. I'll get it back to 300. So this is how we can easily model the section property. Also, we have sketching tools available in this define section window. Very easily, we can simply sketch the outline of our section and generate our section property. The program will automatically calculate its stiffness properties. Alright, so we are done with the beam section property dimensions, and let's provide it a name. We'll call it as beam, and we'll select C30 as the grade of concrete from here, and then click on apply. So that makes a beam section property definition, which we can see from the model tree menu right over here. We'll create another one for the column, and here we will specify the size of 500 by 500 and click on Insert Template. We can change the name from here as column and click on Apply. And after we are done with definition, we'll close it. We have beam and column definitions. Now let us define the thickness for our walls. Well, we have over here 150 thickness and 300 mm thickness. And yes, we are also going to be modeling slabs. So the slab depth is 150. These are predefined ones having material property of C3037, which is as per Eurocode. So to just change the material property of these thicknesses, we can simply right click on it and say change material strength. Select C30 grade and click on OK. Similarly, we can change the grade of concrete for T300 and click on OK. If a new thickness property has to be defined, then from here you can click, select the material and provide the thickness information. Let's say 0.35. The name will be automatically generated, however you can still modify it. and we will see another thickness property generated. So this is how we can define the section properties very easily in Midas nGen. Now let's start creating members out of the grid lines that we have. We'll go to the Structure tab, click on Convert into Member, and select the column. Select the section shape for the column and simply drag around the entire grid line. The program will automatically select only the vertical element or vertical grid lines. Click on Apply and we have our columns. Similarly, we can go ahead to the beam. Click on the scroll button and we can access our front view. Select the horizontal grid lines, scroll button, click on Home View, select the section property that we have defined, beam, and click on Apply. So this is how we can actually create or convert our grid lines into members. You can press Escape from your keyboard to come out of the command. Now there are some elements that I do not wish to use. So I can click on the scroll button. Wherever my cursor is, I can click on the scroll button and go to the top view. From the top view, I can select the elements that I do not want. So we will just delete all these elements. Selecting them, we have not used control or anything as such, and press delete from the keyboard. Then we can go to the home view by pressing the scroll button, and over here at this location we will create the wall members. Now to go back to any command that we had previously used, all we have to do is press spacebar. It's similar to AutoCAD. Even in AutoCAD, you can press a spacebar to run the previous command. So similarly, we have it over here. It makes it very quick for us to use the commands to come inside and go outside of command. So from here, I'm going to select a wall type of member and select its thickness of T300. Then we can select from here the type of analysis we want to perform for our wall elements, and further how we want to get the design performed, like using the wall forces or the stresses, the in-plane stresses only. Alright, so now how to create these walls? Simply, again, we will go to the top view by pressing the scroll button, and then we will make a box around all these grid lines. So here back in the isometric view, we can see that all the periphery grid lines were selected, and we can see the preview of our walls that will be generated. So after this, we can simply click on Apply. After clicking on Apply, we can see that our wall members are generated. So it's that easy. Again, you do not need any wall ID for performing the design of these walls. It's an automatic option that we will see ahead in the design part. Alright, now let's see how to create the slab. We will go to the Member tab, and from the Member tab we will click on Slab. By clicking on Slab, we can simply select its periphery elements. So I'll again go to the front view, select all the members. Let's go to the isometric view, and we can see what all areas are used for creating the slab. And after that, we can click on Apply. Wherever we do not want the slab, we can simply select and press Delete. So that's how you can easily create the slab elements by just dragging around the entire floor plan. Now there is another advantage that I mentioned earlier regarding Midas engine, modeling in Midas engine, and that's about the drop slabs. Midas engine is capable of creating plate beam type of elements, which are nothing but are deep beams. To create these deep beams, it's very easy. I'll show for this particular panel a drop slab. For that, I'll have to delete these slabs, these beam members. So here let us filter only for the beams, and we can easily select the beams only, nothing else will be allowed to be selected. Alright, so these beams are selected. Now just press delete from the keyboard and we will go to the beam, plate beam. Here we can select the thickness for our beam. So 300 or 350, whatever is the deep beam's thickness, we can select likewise. Provide a depth over here of let's say 750 mm, so 0.75, and then simply click on 2 points to create such a beam. No need to click again to create the continuous type of plate beam. So I'm just clicking ahead. To finish, I press escape. No need to click on apply. So we have got our plate beams over here. Now to drop this particular slab, all I have to do is use a move command. Now the CAD type of tools in Midas engine are very easy. So you can simply click on the command, select the member and click on this select by 2 points and specify what the height you would like it to go. So here we can specify 0.75 or you can even specify it at the center. There is snapping tool that can help you access to any part of your particular depth of your particular beam. So yeah, you can get it to the middle and that's how you can see over here the generation of a drop slab. So this is how easy we can get the drop slab generated in Midas engine. Makes it more practical. Alright, so that is how we can create a drop slab. Now let's see how to create more number of stories. For that, firstly, we will go to the Structure tab and define a set of stories. We can actually select different members for different set of stories, and then accordingly we can select that group to perform the analysis. So here this we have got one set of stories. Also this is useful in case of multi-towered structure. So yes, multi-towered structure can also be done in Midas engine, analyzed in Midas engine. Let's click on add new story and we will, no, sorry, not add new story. We will firstly auto-generate the story data to select and find out the story that is automatically there available for us, basically using the members, and click on OK. Alright, now due to the drop slab and the plate beam, the program has detected 2 additional levels. So we can select those unnecessary levels and delete its data only. After that, we will go ahead and add more stories about this typical story that we have generated. So click on add and we will say more number of 5 stories, like more 5 number of stories, and we will insert it at the top level. And we would like to select the slabs and the bottom beams and shear walls. And after that, we can simply click on OK. So this is how we have generated the entire building. Now here, as per our presentation, we would like to have two number of stories at 4 meters height and further 3.5 and further 2.8 meters. So likewise, we can generate the information for there are two stories of 4 meters, then there is 3.5, then 3.5 again, then 2.8 and 2.8. Good part about Midas nGen is that this is Excel compatible, so you can copy paste your levels over here directly. As we change the height, it is all reflected in our model. Okay, so there are some bays that we are going to be deleting, and that can be done easily using our 3D mode, wherein you select your members. Now this has been filtered. Let me unselect all and select all again, or we could have just selected all everything at once. So here from right to left, I'm selecting these members. So not only the members that are in front of us are selected, but also those lying behind are selected. So these members are selected, and now we'll press delete. We can go to the left side view by pressing the scroll button of the mouse. Why I'm actually explaining this again and again is because it's very convenient to go at any view wherever your cursor is. It's a very quick option. So here I'm going to delete these bays, and this is how my structure is generated. Now this is not only the end of modeling. I would like to also showcase how easily we can create openings in the walls. We looked into the 3D mode, we looked into the story mode. So now let's see how we can use the plane mode. So here, click on plane and simply select on an element lying in that plane, a 2D element lying in that plane. So here for these wall elements, we want to generate openings. All we have to do is go to this body tab. Body tab is where you get sketching tools. You can draw whatever you wish, however you wish on a 2D element and create openings. So let's see how that is done. I'm going to use line and I'm going to draw the opening, which is actually my door. So here I'm keeping it a height of 2.1 meter. So I'll write 2.1, press enter, and here I'll have this go on till 2.1 meter again and get back on the ground and finish this opening by getting back to the first position. I'll right click on the mouse to come out of the command. I'll hide the thickness of our walls so that we can see the wall opening easily. It's also easy to move this particular opening at another location. So moving is just simply click on move, select the things or body or members, and then simply drag it to move and click on apply. So it's that quick, it's that fast. Now I would like this to be I'll just make it a little bit in the center. All right. Okay, now I want this particular opening to be generated for every floor. So I'll go to the copy command right over here and select all these body lines again. And I'll use this select 2 points method and simply click from one place to the other place. That's easy for me. And snapping is already done by the program, so I don't have to worry much. Yes, that's it. Right click to come out of the command. So we have got the periphery of our openings. All we need to do, press escape, go to the member and use the opening command. In this opening command, we can select the peripheries. So we have these periphery right over here. I'll select all of these at once and then click on apply. So as you can see over here, we have successfully generated the wall openings at every floor for our wall in our shear wall. Let's go back to the 3D view and we will see the thickness or turn on the thickness again. So openings for the walls are done. Let us also see how we can create openings in the slab. So for that again we can use the plane mode and select any slab on which we want to create the opening. So I'm selecting this one and over here I'll create a body, a circular one for a circular opening. So I'm selecting a center point and making a big circle right over here of 2 meters and press escape. Then I'll go to the member, click on opening and simply click on this edge. The program is going to help us with a preview and then click on apply. And here we go. We have got opening generated for this particular slab. Now, as you can see here or observe here, all these slabs that we have modeled are having two-way type of load distribution methods. This can be changed. It's very easy to do that. You can simply go to the top view. Let's say you want to change the load direction for all or type of load distribution for all these slabs on all the floors, like all these slabs on all the floors. So they are selected all at once. And then you can see here in the properties menu box, the load distribution is two-way. We'll change it to one-way. So it's that easy to do the modification of the load distributions. Now these all are like too much of information on the screen, so we can simply clear our screen from this model tree menu. To undisplay anything, all we have to do is uncheck that box. So references for the planes are unchecked. There are grid lines with us, so uncheck those grid lines and we are free of them. Alright, so that's about the model generated in Midas nGen. If there are any duplicates, you can check using this check model tool. You can just click on check, and if there is no information over here, it means that there are no duplicate members. Alright, now we will go ahead to the loading. In the loading, we can start directly defining the self-weight. So in this self-weight definition, we will go ahead firstly to generate some load sets. And while creating analysis cases, we can select which load set is to be used for the analysis. I'm having a name over here for the dead load and another name I'll create for the live load. The live load type is very important because according to this type, the program is going to automatically generate the load combinations. So self-weight to apply, the factor is automatically given as -1. All we have to do is click on OK. After that, we will go ahead to apply the slab load on all our slabs. So for that, we will click on the slab load right over here and click on slab load type. Now, unlike other software solutions, you do not have to apply different load sets or different load cases to a particular slab. You can do the dead loads and the live loads. You can apply dead loads and the live loads all at once to selected members by simply specifying over here the information. Now this is a Newton per meter square, so I'll change the unit system from here to kilonewton meter. It becomes easier in that way to give the values. So it's a slab load type 1, dead load, live load of -1 and -2.5 respectively. We provide the minus sign so that the program understands that the load is having a direction negatively downwards, or rather in the downward direction. Alright, so after this slab load definition is done, we will go ahead to assign this slab load. So slab load, select all the slabs, again making a box out on this entire building, and then click on OK. So the slab load has been successfully applied to the slab members. After that, we can apply the wind loads. Now there is auto generation of wind loads in Midas nGen, not just for building structures but also for enclosed area, open area and machine structures. So here we are using the story type because we have a building with us, and after that we can specify the eccentricities. So here I'm keeping none as the eccentricity, and further the design wind load definition. Here we have Euro code, American code as well as British standard. We can specify the parameters as per our site conditions and simply click on this report to see a Word file generated. This Word file basically gives us the information about what formulae have been used for the calculation of the wind loads. After we click on OK, close, we can see the forces that are going to be applied to this structure at every floor level. So this is a table that is generated, and it also can be taken into Excel sheet format. In case you're not using the British standard but some other standard, then you can still apply the wind loads floor by floor or story by story to this structure. And for that, all you have to do is copy from your Excel sheets the calculated forces and paste them right over here. So that's it that we need to do in case you're not using the codes that are available in Midas nGen. Alright, so definition is done, and at the same time we can apply the wind load in the X as well as in the Y direction. We'll click on OK, and we see these arrows that show that wind loads have been successfully defined. We can also confirm the loads that we have applied from the analysis tree menu: static loads, dead loads, live loads, wind loads. So both the direction loads are applied at once. Now the static seismic loads. So again the procedure is same. We'll have non-eccentricity and define a design load. Again here we have got American standard and European standard for the seismic analysis. We can specify again over here the parameters as per the site conditions and the approximate period definition, which in Midas nGen we have as like calculator. You can choose the formula as per your structure and simply click on calculate and click on OK. So we get the approximate period from here. And again we can click on report to generate a Word file that can help us to know about the formulae used to get the forces or the shear forces. We'll click on OK, close, and see the profile which shows the base shear even before performing the analysis. Okay, and to apply the seismic load in both directions at once, check on the ortho option and provide the scale factor for the same. Click on OK, and seismic load in X and Y direction have been successfully applied on our structure. Alright, even imperfection loads are available, as in case of British standard we have got notional loads. We usually compare the notional loads with the wind loads, and whichever is prevalent is used for the design purpose. So to apply this notional load, we can simply go to the initial sway coefficient. The program automatically calculates for Eurocode, but in case of British you can use user defined. We can specify over here the coefficient, which is 1.5%. So I'll make it 0.015, copy it and paste it for all the levels in both the directions. So after that we can click on OK and assign this imperfection load by specifying the load cases or the gravitational loads which are to be converted into lateral loads. So you can specify here the dead load and the load case and the scale factor on it and click on OK. So that's how we apply the notional loads. That's about the loading in Midas nGen, and now we'll move ahead to the boundary conditions. The most basic type of boundary condition are the supports. In case of supports, we have got predefined fixed pinned type of conditions. For a building, we are going to be using fixed. And if in case we want to make it user defined, just uncheck the boxes. By checking on the boxes, the translations txt by tz and the rotations rx r by rz are constrained. Now to assign these supports, we need to select the points. And those points are going to be at the bottommost level. From the front view, we can click on OK. Click on the scroll button again. Going to the isometric view, we can see the entire structure with its boundary condition. Next part is about the diaphragm. Now rigid diaphragm, semi-rigid diaphragm can actually be specified from here. To define this diaphragm, it's very easy. Simply from the top view, we can select the members that should be included in this diaphragm. To unselect anything, we can press Shift from our keyboard and select that again, those elements again. Alright, and after that we can simply click on OK. So as you can see now in this isometric view that the program has successfully found out the center of mass and connected every member to it rigidly. So that's about the diaphragms, rigid diaphragms in Midas nGen. Now we will go ahead to the loads to mass conversion. Loads to mass conversion is right here. We can convert the dead loads, 100% dead loads and 25 to 50% of the live loads for the seismic load calculations. Here I'm using 25% only and click on OK. So in this way we can see that the mass is applied, diaphragms are applied and the support conditions are applied. And that's the end of the boundary conditions tab for us in this session. Of course, there are many other options available for us to use, and in more advanced videos we will see how and what they are. Alright, now before going to the analysis tab, I would like to undisplay a lot of information that is there on our screen. So just uncheck the boxes. This is for the loads that have been applied. Then uncheck the support condition, uncheck the diaphragm information, and also uncheck the mass information. We can see a lot of like information about these directions, so like one-way, two-way type of a slab. So we can go to the view control and undisplay the slab load direction. And we have now our model very clean to go ahead and check the analysis results. To perform the analysis, we have over here analysis settings. In this analysis settings, we can specify what should be the mesh size, because instead of meshing the model in during the modeling period, Midas nGen is capable of automatic mesh. So this automatic mesh is dependent on the division or the lengths that we provide. It also has got a smart size feature. So according to the size of the model, the program has been programmed such that adequate size of mesh will be generated. You can have the analysis speed increased by increasing the number of processors and also by using GPU accelerator. So that's another advantage of Midas nGen. I'll close this and we will go ahead to the next part, that is combination. Here we can select our code, that is British code. We have Euro code as well, and we will click on OK. And we will click on auto generate for the program to automatically create load combinations for strength and serviceability conditions. So that's automatic. We save our time over here as well. Then there is mesh size control. So at locations such as this one, the circular one, we can specify a smaller mesh size. So let's say 0.3 should be the size. We can get a preview over here as well and click on OK. So that's mesh size control, which we can see from here in the analysis tree menu. I'll uncheck that as well to turn off its display. Now we have an advantage in Midas nGen about creating n number of analysis cases. So you can actually select different support conditions and different loading conditions to perform the analysis of a model. Within the model itself, you can have different members included in the analysis. So here we will click on OK and simply go ahead to run the analysis. So I've saved the model file and I'll let it create its own analysis type of members. And we will see how fast the program is able to perform the analysis of such a big structure with several number of elements that would be automatically generated after performing the mesh. Also, one good part about Midas nGen mesh is its quality. The mesh is always taking care to have an aspect ratio close to 1, which gives more accurate results. Also, it takes care to connect every member with each other. So this is the analyzed model in front of us. Now we will go ahead and check the analysis results. To check the analysis results, let us see this analysis tree menu, analysis results tree menu. Here we can see the deformations due to dead loads by simply double clicking. To see the deformed shape of the structure, we can check on this deform right over here. So this is the deformed shape of our building. This is only due to the dead load. We can select over here any combination or even the serviceability envelope. So as per the serviceability envelope, we have maximum displacement of 19.48 mm, and that's available at locations where it's pretty red. Alright, so this is a legend which we can move anywhere. Let's get back to our kilonewton meter unit system and see the reactions on our screen. So I'll just double click on the vertical reactions and check on the values option and see all the values at all the locations where the support is applied. So here we can see the information about the vertical reaction in the form of legend as well as in front of us on the screen. Alright, so that's about the reactions. Then further we'll see the forces. That means we'll see the bending moment diagram and shear force diagram. So let's look into the actual force diagram of our columns. We will undeform this structure and uncheck the values. So we can see the actual forces which are more prevalent in the column members. And let's look at the bending moment diagram for the beams, and we will go to a particular story for that purpose. And let's go to the roof level. So in the roof level, we can see over here, this is how the program is showing us the beam bending moment diagram. And if you would like to go to a particular plane and see the results, that's also possible. That's about the bending moment diagram for the dead loads. You can go to any other load to check the results. This is a lateral load. Alright, so that's about the bending moment diagrams, beam diagrams. We can similarly see the wall forces or the wall diagrams. So we have walls right over here, and for each wall the results are visible on our screen. Alright, so that was about the analysis results which we can get in the form of display. We can also get the same results in the form of tables. We can expand analysis and we can get the tables generated right over here. Can select, initialize this, a particular beam, and for that beam we can select and see what the results are actually there. So that's about the forces for the beam, and further we can look similarly the results of story, like the story drift. So in case of story drift, we check with at the center of mass for seismic, or at the end locations, or the maximum location of deflection or displacement or drift. And for that we need to simply specify the parameters. So here we can specify how you would like to see the results: maximum drift of outer extreme points or maximum drift of all vertical elements. Likewise, we can select and provide an allowable ratio over here. So 0.002, likewise we can specify and click on 0.015, I think that's correct, and click on OK. So this is about the dead load. Let's select the seismic load set, and we can see here the remark given as OK. The story drift ratio is automatically checked with the allowable story drift ratio, and the program provides us a remark if the drift is within the limits or not. Similarly, we have various story tables available with us which can be taken to Excel sheets. So that's about the information about analysis results. Let's look into the design that is provided by the software. In the design, we can just get to the initial view, clicking on the scroll button and going to the isometric. Here we can specify over here the design settings. In the design settings, we select the code and we can select the parameters required for performing the design and the material property. So here we are going to specify the British standard for the reinforcement, and we can select what all reinforcements are required to perform the design. So for beams, for columns, for plates, walls, we can go on giving information like you want all these diameters of bars to be utilized for coming to a good optimized result. So that's about the rebar arrangements. Then further, the grade for main reinforcement 460 and for the shear rebar grade 460, that's what we have selected right now. Then the rebar arrangement, if you would like to provide your own reinforcement arrangement, then the default ones can be provided right over here. When it comes to slab reinforcement, alternate kind of option is also available. So you can have alternate reinforcement considered for the slab, and you can select which all are going to be utilized in case of the slab. So selecting that, we can go ahead. Yeah, there is checking control as well. You can specify your target ratio, demand capacity target ratios right over here. And you can specify over here as well for separate members. And further, there is a criteria for strength check. So strength check is a good option in the design case in Midas nGen, wherein the program is going to see if your member is lying between a particular range of demand capacity ratio. So for example, over here, the default is if your demand capacity ratio is coming between 0.6 and 0.9, then it's okay. If it's coming between 0.9 to 1, then it is critical. If it is going beyond 1, then it becomes not good or failed. Need check is the one when your member design is less than 0.6. So maybe your sizes are too big and you need to reduce them to optimize. Then there is failure wherein the member is absolutely absurd. And not check is when you have not included a particular member for the design purpose. So that's about the information that we can specify in the general design settings. Combinations are already created, so we can simply go ahead to create the design groups. This is again an automatic option. The program will select automatically all the members and create and put them under separate groups. So this is basically how they are all put under separate groups. So that's set. And now we will go ahead to perform the design. So let's create a design case, and again we can have n number of design cases that includes a set of load combinations and a set of members. Then we can click on OK, and we can go ahead to run the design. We can ask the program to arrange the rebars automatically and click on OK. So the program is right now performing the design of all the members. The groups are important because without the groups, the program will not be able to generate the drawings. And we would like to get drawings automatically, right? Instead of waiting on to the draftsman, we can generate the structural plans, elevations, and the rebar detailings, rebar bar bending schedules by ourselves. So here we have the design performed for our structure. Let's look at the strength check status, or we can even see the total status, the strength and serviceability status. So as you can see over here, many of our members are blue in color, and blue indicates, as per this legend, OK. So most of the members are economical, and then there are some critical members as well, and some of the members have even failed. To see the design results in different formats, we can go to this information, tabular information. So let's look at the design results for in the form of tables. So we can expand the design and expand RC result table and check for each member separately. So we can select a particular member and see the information, its demand capacity ratio. This is one form of tabular result for different members. We can also get such a tabular result in an RC section. However, over here, we will get the reinforcement arrangement. I think this is what mostly engineers would like to have, the information about the reinforcement arrangement tabulated nicely. Now, in Midas nGen, you can have your own reinforcement. You can modify this reinforcement and get it checked. For example, over here, instead of like 4 rebars, you choose 5 number of rebars at the top and 5 numbers at the bottom. And then you go ahead. Alright, this is checked on. You just go ahead and click on redesign. So after you click on redesign, the program will perform the design again, and it will show over here the newly designed information. So it's still critical, because the reason why it is it's more critical is because of the long-term deflection or the serviceability condition, that is crack. So it's fine all along for bending, negative bending, positive bending, shear. Yeah, it's having problems in the positive bending, so maybe we can increase some reinforcement for the middle. However, there's a possibility that maximum reinforcement limit must have reached. So there are various ways in which you can modify this particular section. You can even change its section shape or size. Let's click on close and see different types of results. Other than that, we have design report. A report in the form of a summary is generated on a Word file. So you can actually select your members. I'll select each member, and we can click on OK. So a Word file will be generated by the program, as you can see here, in a very short period of time, wherein we can see the dimensions of our section and also the reinforcement arrangement. We can get to see the demand capacity ratios and remarks over here. This is for the beam. This is for the column, wherein we get the PM interaction curve as well, and the demand capacity ratio information. Then this is for the shear wall, the demand capacity ratios and the PM interaction curves for major and minor axis. This is for the slab. Conventional type of slab is being like designed over here. So it has automatically detected that there are two adjacent edges discontinuous. So it's correct, two adjacent edges, this one and this one is discontinuous, and accordingly the program has performed the design of this particular slab. So it's pretty efficient and automatic, also optimized, because it's taking care of getting the ratio between 0.6 and 0.9. Then let's go ahead to the next part, that is the design report in detail. So instead of knowing what is the general design procedure adopted by the software solution, you can see what is its actual calculation. So you can select any member, and you can click on OK, and the program is going to generate another Word file wherein we can see the different load combinations, and we can see that the moment check is there, shear capacity check for the positive and negative side, and then shear is at the end. This is for all the sections, I end, middle end, and the J end, both the ends, positive shear and negative moment, positive moment, and shear check. And after that, there is serviceability check done by the program. Crack width check is performed. Negative and positive. And deflection check is also performed by the program. Long-term and short-term deflection check. So design, I think, is completely fulfilled by, design part is completely fulfilled by the program. Formulae are given, and we can also see there are some references provided, so that if you're using any other code, I mean, you're going to be using Eurocode in future. So in that case, instead of searching many design standards, Eurocodes are actually comprising of several standards within it. So you can simply take these references, go over there, and check what exactly the code has been specified. So this is how efficiently we can get the design results in the form of Word file using Midas nGen. Now we will move ahead to see the reports and the drawings generated by the program. Let's click on this generate report, and we will open a new report maker. Report maker comes along with Midas nGen itself, and it's a very efficient tool of creating a report. You can add a cover. You can add a table of contents in it. Then if you want to add some external picture, you can do that. User-defined text can be added in between anytime. And project information, then material properties that have been used in general. And then further you can create chapters. So maybe you would like the table of contents after all this information, and you would like to add a chapter. So right click on this and say add chapter. You can give it a name. So let's provide a name over here as modeling. And under the modeling list, so these are basically the lists of results that we can input or put inside our report maker. So analysis model, double click, load combinations for RC, and then you can create another chapter for the loads. You can name it as what all loads are included in this particular model file. So now you can include the information of wind load profile, seismic profile, and further you can specify the dead loads and the live loads that have been utilized. Alright, and after that you can move ahead to the boundary conditions. So let's make another chapter for that. We will call this chapter as support. And we will simply double click to add the support information, the diaphragm information, and anything else that have been included. Coming to the results, you can right click, say add chapter, and specify over here analysis results. From here we can take the analysis result information like beam forces, wall forces, and reaction force table. Then let's include some design results. So let's add a chapter that shows information about design that has been performed in the software for the model. We have design results over here, so we can specify over here the total result, which gives a table that can be just viewed in a glance and understood by looking at them if any member failed or did not. So I mean how the member has passed. Also within these results you can select which all members or which all load groups you want to put in this particular report maker. So that's about the report list that we have created. This list can be saved for your future projects. Now I'll click on generate over here so that the program will take all this information from our model file. This is our file name, final, and its date. We get a nice view of our entire model. Then further, the contents, a table of contents is there. We can introduce page breaks at every different chapter or every different location. So there are page break option as well. So we have the information of our material properties also utilized. We can see the model and the load combinations that have been used for the analysis checks and design results. Then further loads, what all loads have been applied. We can see the dead loads and live loads in the form of image itself, and support conditions applied, the diaphragm applied. Then coming to over here the analysis results. So this is actually an entire view. We can specify a separate view for a separate location. So we have got the bending moment diagram, shear force diagram, axial force diagram, and also we see here the diagram for the wall forces, so shear force, bending moment, and axial forces. And we also get the results in the form of table. So this table that you can see over here, this is for the reactions. So the name of this table is given at the end, reaction force table. Then further coming to the design results, this is, sorry, let me go down. Yeah, here we can see the design results. This is in the form of table. We can see the design code right over here specified and the status. So the status is okay, critical, and at some places it's not good. So this is how you can generate a report in a report maker from the analysis and design results of Midas engine. Now in case if there is any modification in the model file, then let me give an example. If you do not have a column right over here, I'll go to the pre-processing mode and delete it. Yes. And I'll reperform the entire analysis and design so that once we can run everything all over again. Alright, so the analysis is being performed right now and we can see that being performed at the bottom. This is a progress bar that shows this information, and there is a message window also at the bottom that helps us to know what it is going through while performing the analysis. Alright, so this will take very less time now since it has collected all the data that is required to perform the analysis. The analysis is completed. Now it is going to start performing the design. So here's the design that is being performed. Design is performed. Now let us get back to the report maker. In the report maker, we will simply check and update. So it identifies there is difference, and then we'll click on generate. The program is going to basically create the entire project report as per the latest model file. This saves a huge time required to create the entire project report. So if you have spent an entire day creating a report file for a project, and similar type of a project is there, or you have some modifications, then within one click your entire project will be created. So you can see here there is a change in all the images and of course the results. And after this we can export this report into a document, Word document. You can save it with a name. That will generate a Word report that you see over here itself, and you can further use it to create PDF files or image files as required. Yes, so this is about the report that is generated in the form of Word file. Right, I'll get back to Midas nGen and we will move ahead to the report and drawing tab again. Now this time we will generate the drawings. So generation of drawings is also very efficient in Midas nGen software solution. You can generate the structural plans, the structural elevations, and the rebar schedules or the bar bending schedules using an automated process. So this is Midas drawing software solution offered by Midas nGen. You can see over here in the settings of drawing the structural arrangement. So you can create or modify all the settings as per your practice. So after you're done, you can set the rebar arrangement style, which again we can see over here is as per the British standard. But in case you would like to modify anything again, then you can click on set rebar fabrication lengths or splice methods and do those modifications. Specify your own length values for the splicing, development lengths, and so on. This is separately for general beam, column, rebar schedule also can be generated. We will see how efficiently it can create these all information. So firstly, I'll generate a certain number of floor plans. I'll create one for the ground, one on each level, typical level, and click on OK. So we have our floor plans and we can specify their location. This workspace of Midas drawing is very much similar to AutoCAD. So if you're proficient in that software, you'll be able to use this very easily. So we have over here our floor plans for every story. This is foundation level. Then this is our floor level. You can see over here, this is an opening. So a cross mark is given. And this is a drop slab, so it has been hatched separately. Then further you can see the floor plans and you can see this is the opening in the wall. Very efficiently we can see the information for the structural plans generated by the program. These are the structural plans. We can also generate the rebar arrangements for roof beams or for any type of beam or girder. So I'll click on OK over here to show you how the rebar details are provided. Basically, we can see from here the rebar schedule provided by the program. Here we have the information in the form of longitudinal section. These lines that you see over here, these are the reinforcements at the top and reinforcements at the bottom. You can see the splice lengths, you can see the entire length of a bar that is utilized. Curtailments of the bars also, you can see that information. You can get the rebar schedule from here itself. So the rebar shape is given, the shape of the stirrups is given, the length of the rebars is there, what diameters have been used, the quantity of the rebars, and the total length. Furthermore, you can see the weight of the rebars as well. You can specify firstly the unit weight, and then you can provide over here get directly over here the rebar information, rebar weight information. And there is a key plan which explains which location of the beam is displayed right over here. What is the location of the beam being displayed over here? So that's these are the rebar schedules for the beams, and similarly we get the rebar arrangements for the columns. So I'll give one example right over here of a column. So columns for every floor height is provided, and the reinforcement arrangement as well is provided over here with the sectional view for the rebar arrangement, and the ties also. So this information is here. The location of our column is shown over here in the key plan, and the rebar shape information as well. That's about the rebar drawings. Then further we can also get the drawings for the I would say this is for, let's see, for the wall, and we can see for the slab as well. So this is the information. This is just one method in which we can get the wall results. You can modify this information. You can, there are various types of display for the walls. Similarly over here we have got typical drawings of the slabs, and you can specify which type of slab reinforcement arrangement is to be utilized. So this slab design is in the form of table right over here that we can directly get. Alright, so not just these drawings, Midas drawing is also capable of providing a bill of material So we have only RC over here, so I'll not ask it to create any more pages in the Excel sheet. The Excel file is generated automatically by Midas Drawing, which displays the bill of material. So the bill of material is generated right over here. This is our cover page and the bill of material information in the form of table. As you can see, this is where the group names are given, the type of member. Firstly, it's type of member, then the group, and then further what section properties have been utilized, what's the length, the quantity of the same length of beam, total length, then the concrete volume in meter cube, we get rebar weight in ton, and formwork also, formwork area is given to us in meter square. So this is for every member, and finally we get the summation of all the results